Hi! In this video, I'll be starting off the game theory series after the introduction by first starting with the simplest type of game, which is known as the static game with complete information. So what does it mean to be static? It means that it is a simultaneous game where every player makes one move. So you don't know what your opponent is going to be, and you don't really need to care about it because all of you guys are making your move at the same time. So in this case, because you only have one action and one strategy, then this is known as a static game. And what does it mean to have complete information is that you know everyone's playoff function. It means that you make a move, your opponent makes a move, both of you will know the payoff that you will get using this action profile or strategy profile. They are the same thing in this case. So a common example is the prisoner's dilemma. As we see, it can be represented by this bi matrix, where if both don't confess, then they both go to jail for 1 year. If they both confess, then they both go to jail for 6 years. So in this case, we use this bi matrix to represent this type of static games very easily. But the problem is now it cannot be generalized into too many players or or if players have different strategies. But we'll see more of those examples later on. And with a static game, we can introduce what is a norm-form representation of this game. And basically it is something like the definition of the game, but now you write it in a more formal way, where we introduce it to be a number of players, the strategies that each player takes, and what is the payoff function for every player. So in the case of the prisoner's dilemma, there will be only two players. So you got S1 and S2. So S1 is just confess or don't confess. S2 is also confess or don't confess. And then you just read off the payoff function here. And this is basically the formal way of writing the bi matrix. So we see that no matter what P2 confesses, P1 will always choose confess for better payoff. You see? So P2 can choose, so P2 is represented by the columns. P2 can choose either don't confess or confess. But in any case, so if you take this case first, we see that the better payoff is to confess. And in this case, the better payoff again is to confess. So P1 will always choose confess no matter what. And we call this a strictly dominant strategy, while don't confess is a strictly dominated strategy. So what does it mean by a strictly dominant strategy? Well, an action that strictly dominates another action is when in either cases of the opponent's action, you have only one strategy or action that always has a better payoff than the other. So in the example we gave with the prisoner's dilemma, confessing will always be this strictly dominant action. And a rational player will never play a strictly dominated strategy because he can always improve his or her payoff by using the better strategy. Because if you are dominated, then there will be some action that is better. And you will also know that because of that, we can also assume that our rational opponents will also never play a strictly dominated strategy. So we take an example of why we say we never play a strictly dominated one over we always play a dominated strategy, a strictly dominant strategy. So let's just say A strictly dominates C. Because if case 1, if player 2 chooses X, you choose A over C. If player chooses Y, you choose A over C again. So A strictly dominates C. But there is no strict dominance between A and B. So you can see it's more easy to cancel out the strictly dominated strategy. So in this case, player 1 can choose either A or B because you don't know what player 2 is going to choose. But you definitely know you will never choose C because if this is given the option, you always choose A over C, and then A and B has no much difference. So this one will be, you have to do a mixed strategy for this, but you know you can cancel out C. And this leads us to another thing known as the weak dominance. So in weak dominance, it basically means you are strictly or equal to any other strategy for the action, but you strictly dominate one other strategy. So you need to find one other strategy that you dominate. So, for example, in this case, M strictly dominates T, but only weakly dominates B. And B weakly dominates M. Why? Because in this case, B playoff is always larger than T. So you see, 1 here and 2 here. So B is always better than T. Then, but if you consider B and M, here is larger, but here is not. So there is a case where B weakly dominates M because you only are larger or equals to than M. So a strategy is weakly dominant if it weakly dominates all other strategies, and is weakly dominated if it's weakly dominated by at least one strategy. And with the previous example I've shown you about here, we'll never choose the weakly dominated, the strictly dominated one. Then we have this process called iterated elimination of strictly dominated strategies. So what you want to do is you find the strictly dominated one and then you cancel it out. So for example, we have this by matrix. So usually in player 1, neither up or down is strictly dominated. But for player 2, right, if we fix up, then we will definitely choose middle over right. If we fix down, we will again choose middle over right. So in this case, right is strictly dominated by middle, so we can cancel this out and we are left with this. Now that down is strictly dominated by up in this case, because once you have this, then we see that if player 2 choose left, then you choose down. If player 2 you choose up. If player 2 choose middle, you again choose up. So this is again strictly dominated, so you can cancel this, and you're left with the following space. So iterated elimination is one of the basic principles, and it can be useful to analyze games. But it only determines what strategies to be taken out. It only determines what strategies you would not take out. But what strategy should be ruled out, it determines not what strategy should be taken, but what strategy should be ruled out. So you can only cancel strategies because you know they are strictly dominated, but you cannot choose strategies. So what's happening now is, for example, now we have this thing called the branch or Skavatsky, or also known as Battle of the Sexes, because you can, if you go online, you can read it about it. Why is it also known as Battle of the Sexes? Anyway, the BOS game is giving you this playoff matrix, and if we see this playoff matrix, we can model the situation by the following. And if you see this now, there is no dominant strategy in any case. Okay, so if player 2 chooses bug, then you choose bug. If player 2 chooses S, then you choose S. So you see, and vice versa. If player 1 chooses bug, then you choose bug. If player 1 chooses Stravinsky, then player 2 again, you compare 0 and 2, you choose S again. So there's no strictly dominant strategy here. So in this case, IES-DS fails to work, and so we'll need another notion or another model or another concept, and we'll introduce that in the next video. So stay tuned for the next video, and I'll see you again. Bye!